Oh, looks like Cuckoo is up bright and early. Cuckoo. And he is excited too, because we are going to be learning a new math topic today. Which is positive and negative numbers.
Wow! I've waited all day to learn about this topic.
Ooh.
What's this? I think this is the head start.
I think you're right, Sibby. Whoa, what's going on? Whoa. Why is there a person diving in the water? And why are there yellow and red circles over here? Just whoa. Okay, Byron, settle yourself down. It's not that complicated. Just calm down and take a step back, because we are not getting there just yet. We need to learn the basics first. Okay. So what we are learning today is a very special math lesson about positive and negative numbers.
Wow, can we see?
Yes, Romeo and Juliet, you can absolutely see for yourself.
Ooh. Wait a minute. The cliff diver below is poised to dive from the top of a cliff that is 60 feet above the water.
60 feet above the water? What does that mean? If it is 60 feet above the water, that will be a positive 60, because when something goes above, it usually goes up or increasing. That's usually positive. So it can be like your mood. When you're being happy, your mood increases into a happy state. That's a positive state, positivity. And 60 feet above the water must be a positive 60. So it's a positive 60 for the traveling above the water. If the distance she travels underwater is about 1/4 of the distance she travels above water, how would you describe her location at the deepest part of the dive? Okay, before we even get into there, let's explore negative numbers. I think you guys should all be familiar with the number 0, right? It's like an empty hoop. It represents nothing at all, and it is a neutral number, not positive or negative at all. It's right between the number line of positive and negative numbers. Well, negative numbers are very, very unique from positive numbers. You wanna know why? Because they're less than 0.
What? Less than 0? Yeah. Is that real?
Yes, Squeak, negative numbers are real, and we can even represent them in the real world. 0 minus 1. Oops, sorry, made a mistake. Anyways, 0 minus 1. It looks like this one doesn't work. Oh, wait a second. I didn't see the minus sign over here. This is the tiny minus text and the minus sign next to the minus text. The minus sign in front of a negative number will always be present, because negative numbers always have minus signs in front of them. The minus signs tell us that the number is negative. So -1 or -1 are both ways to say -1 or 0 minus 1. That's -1. And if we add 1, that would be 0. Amazing, right? When you add a negative number to its positive opposite, you'll get 0. Like -5 plus 5 more. -4 plus 4. They both cancel out. We're going to talk about opposites in a minute. But first, let's try to solve this problem. Okay. She travels underwater about 1/4 of the distance she travels above water. Well, for a start, how high above the water is she? 60 feet? That's right. She is 60 feet above the water. And underwater is 1/4 of that distance. What's 1/4 of 60?
15.
Yes, 1/4 of 60 is 15. And now, if we're going to go below the water, then it will not be a positive number anymore. What do you guys think it will be? A negative number? That's right. If we go below the water, then it goes down. It's like being sad or filled with negativity. You're going down in your mood. So yeah, that's how negativity works. Less than 0. So this is less than 0 at sea level. Sea level is a very important concept. Sea level is basically the level of the water. That's all it is. Although sea level may be easy to understand, sea level may also be very complicated because lots of sea levels are presented in keys. But anyway, let's get back to this basic sea level. If the sea level is 1/4 of 60, which is 15, then it must be a negative amount. So it would be negative 15.
Cuckoo?
That's a great question, Cuckoo. Why is it negative 15? Because remember, as we talked about previously, if you're under the water, the distance will be a negative number because it's below sea level. When you go below sea level, the depth will be negative because as you go down, the negative also goes down. So, yeah. When you reach a negative sea level, you're going below the water. So when you're going underwater, you're going at a negative distance. But when you're above the water, or if you're at 0 sea level, then you're at a positive distance. Unless you're at 0, in which case 0 is not positive or negative. It's in the middle. So if you're above sea level, then your distance will be positive because it is out of the water. It's out of that negative depth. So if you're underwater, that's a negative number. It's the negative depth of the water. Now, the depth itself is not negative because it's 15 feet below the surface, and 15 is a positive number. But negative 15 counts as a negative depth representation, which theoretically counts as our, quote-unquote, negative depth, because it's 15 feet below the water. So that would be negative 15. Because it goes down. Negative numbers go down the number line. Okay, that was quite a challenge. But now, let's try the harder challenge. What pictures do you see here? Oh, wait a minute, they're not just circles. No, they have signs on them. Wait a minute, is that a plus or a minus? They have pluses and minuses. Wait a minute. Each of them has either a plus or a minus. But what do those mean? Great question, Byron. What are those tiny little circles with the plus and minus signs in them? Are they the positive and negative number signs? Theoretically, yes, if we look at it from a point of view, but that's not what I'm looking for. Look at those tiny little dots. What do you notice about the pluses and the minuses of these dots?
Oh! The positive dots may have something positive in common, and the negative dots, negative in common.
That's right. If a negative dot appears, I think it must have something negative in common. Let's read the text. Protons and electrons are parts of an atom. A proton has a positive electrical charge, and an electron has a negative electrical charge. What? Wow, so I'm actually staring at protons and electrons now? Yes, but not real ones. These are model protons and electrons. Those are a lot bigger than real-life protons and electrons because they're so small that we cannot see them. Oh! Electrons have a negative charge. So the red circles are the electrons because they all have a negative charge. But the protons have a positive electrical charge. So the orange circles would be protons because they all have positive charges. In this illustration, is there a positive electrical charge for every negative electrical charge? Explain why or why not.
Wow, this is the ultimate challenge. Wait, how many protons and electrons are there?
I have an idea. Maybe we should count all the protons and electrons each to make sure the amounts are equal.
Great idea!
Let's count them. 1, 2, 3, 4, 5, 6 protons.
And 1, 2, 3, 4, 5, 6 electrons.
6 protons and 6 electrons. 6 is equal to itself, so that's equal.
So, yes.
The positive electrical charge, there is a positive charge for every negative charge, right? Because there are 6 of each. That's right, Fudgy. Yes, there is a positive electrical charge for every negative electrical charge. No matter how you organize them, there will always be a positive for every negative because there are 6 electrons and 6 protons, meaning that one proton must have one electron next to it. Look at any proton. What's next to it? An electron. Any electron. What's next to it? A proton. Any proton. Electron again. Electron, proton. Proton, electron. So you see, every proton is there for every electron and vice versa. Vice versa means the other way. So that means every electron is there for every proton. So now you understand protons and electrons. They constitute an atom. Atoms are one of the smallest things on Earth. Although I think quarks can be smaller. Wait, are they smaller? I don't know. Anyways, size is just a matter of debate. It's not really size we're talking about. No. It's rather the electrical charges that are emitted from such particles. We can represent negative numbers this way. Through electrons. Through the red dots. And this is an economical question. Let's see if you guys can change your thinking. Get it? Change? Because money's a type of change.
Oh, that's funny. Change.
A checking account has a balance of $80. Well, that's easy. It's a positive 80. But that's not the full part, though. Read the other text.
Oh, there's more text here.
Suppose a check is written for $100.
Oh, what does 409 stand for?
409 is the check number. You do not need to know about check numbers until much later in your life. But check numbers are simply numbers that are emitted for a specific amount of money. For example, if you have $100, your check number might be 409 because the check number is already there for you. The check number just tells you what amount you will be specifying. 409 is somewhere close to that, but you won't actually be spending $409. No, that's just the number overall. Like, the number of, I really don't know.
There are.
See, even I don't know, so we make mistakes. Anyways, but the check number is a specific kind of amount, we know that. But look at the balance. What do you notice about the balance? That's very odd here. Wait a minute. Isn't it supposed to be 100 minus 80 instead of 80 minus 100? That's right. But in this situation, that's wrong.
There are.
What? Well, you would be right if we are talking about positive numbers, because 100 minus 80 would be positive 20. But it would be wrong if we're talking about this situation. 80 minus 100 is not positive 20. It's negative $20.
Negative $20? How can you get negative $20?
Well, you can't actually earn negative amounts of physical money remains. The only negative money you receive is digital negative money. So, on your bank account.
Oh, yeah.
Digitally, not in real life. No, not really. But in real life, the digital is in real life. See how I can trick you? So, negative $20 is the total amount, because 80 minus 100 is the opposite of a positive 20, and the opposite of a positive 20 is a negative 20. So now let's talk about opposites. Opposites are numbers that have the opposite sign. It's very, very easy. For example, if we were to find the opposite of 6, then we would have to put a minus sign in front of it. So, the opposite of 6 is negative 6, because negative 6 is the negative amount of 6, but 6 is the positive amount of 6, and the opposite of negative is positive. So, think back to kindergarten. Think back about all your opposites that you've learned. In, out, on, off, or yeah, or up, down, left, right. So you see, we could do the same thing with numbers, except it's just positive, negative. It's only one opposite scale. So, subtracting $80 from $100, you will get a debt of negative $20. A debt? Yes, Juliet. A debt is a negative amount of money. A withdrawal is different. Do not get confused by the withdrawal. A withdrawal is the process of removing money, not the actual negative amount overall. The debt is the negative amount, but the withdrawal is the process of removing positive amounts of money. So you see, it's like taking away protons. So if I take away one proton, then there will be 2 electrons at once, and there will be no proton for that electron to be shared up with. Therefore, the amounts will be unequal. So it's the same thing with money, and the same thing with sea level. So you see, sea level, science, and economics are all ways to represent positive and negative numbers throughout our daily world. You don't know it, but positive and negative numbers are existing all around us right now. Right now? Where? Take a look at this cleaning machine. What do you notice? There's a bottom! That's right, and if we measure this bottom, it should be as many steps as I take. So I have 4 legs, so I have to skip count by 4s. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. So it's roughly 40, because I measured it with my 4 feet. That was 10 walks. So 4 times 10 is 40. But remember, that's below, so it won't be a positive 40. That would be a negative 40. Woohoo! Negative numbers are existing around us right now. That's right. And also positive numbers. Walk on top of me. Huh? Okay. 4, 8. That's right. A positive 8. Because look, you're going up me. Huh? Up me. See, you're going above me. And above is a positive value. So it will be a positive 8, not a negative 8. Wow, you're so amazing. I'm a dog, what can I say? Now, anyways, let's move on to the next page. Those are not the only ways to represent positive and negative numbers, though. No, we could do the whole extreme if we want to. We could go to a volcano and measure how deep it is, and represent it by a negative distance. Oh, but we would have to travel very far and be careful not to be burned by the lava. Yes, exactly. We only look at pictures during that. Don't go near a volcano, it's dangerous for you. Okay, anyways, there are other ways to represent positive and negative numbers. As we mentioned before, 2 numbers are opposites if they are the same distance from 0 on a number line, but in opposite directions. So, let's draw a number line. You guys should all be at least a little familiar with how number lines work, right? Left to right. You read it left to right, and all the numbers are arranged. Tick marks are placed to represent each number, and in the middle marks 0. And then to the left are all the negative numbers in place. -3, -2, -1. And to the right are the positive numbers. +1, +2, +3. So +3 is simply just known as 3, because there's no negative next to it. So this is a visual representation of a number line. But this is only a horizontal number line. There are also such things as vertical number lines, or number lines going up to down. Let's draw a vertical number line now. Let's see what that looks like. So now we read it up to down instead of left to right, since it's vertical. At the middle again, we write 0. But the negative numbers go at the bottom, because remember, If you're below sea level, you're underwater. And underwater is below the water. So below it, it would be a negative distance. -1, -2, -3, and so on. But above the water, you're not underwater anymore. You're above the water. So that's a positive distance. +1 and +2 and so on. So you see, the positive numbers go on the top, 0 stays in the middle, and the negative numbers go at the bottom. And on a left to right number line, the negative numbers go to the left, 0 stays in the middle once again, and the positive numbers go to the right. So you see, those are ways to represent positive and negative numbers. Those are only visual representations, though. We can also represent it through temperature. You guys should know what temperature is, right? Temperature is hot or cold. That's it. That's all it is. Like the perceived heat or coldness we feel around our surroundings. Temperature is more complicated than that, but I don't think I can fully remember because honestly, I don't. But anyways, to put in basic terms, it's basically hot and cold. If two temperatures are opposites, they are the same distance from 0 on a thermometer. If one temperature is above 0, the other will be below 0. The opposite of 0 is 0. So you guys, 0 is not a positive or negative number at all. So it doesn't have a positive or negative sign. 0 is nothing. Look, how many ducks are there? 0, right? There are 0 ducks on this painting. The only thing that's there is 0. So the opposite of 0 would be itself. Because anything that there is 0 of makes 0 of that thing. It is itself. So it can't go away from itself. 0 is 0, you guys. That makes sense. That means the opposite of 0 is always 0 and not any other number but 0. Each arrow on the Fahrenheit thermometer points to a temperature. Write the temperature. All right. Fahrenheit is a temperature scale. Fahrenheit is written with a capital F. This is Fahrenheit. And Fahrenheit is measured in degrees. Degrees are the units for measuring positive or negative amounts of temperature. There is another temperature scale called Celsius, with a capital C and a degree again. But amazingly, did you know there's a third temperature scale that doesn't have degrees? What? Yes, it's called Kelvin. Kelvin is a third temperature scale that does not require degrees. It's simply a capital K. Kelvin is completely different from Fahrenheit and Celsius. But theoretically, over here in our region, we use Fahrenheit and Celsius. We don't really use Kelvin very often. Kelvin is more for, like, powerful temperature experiments. Like measuring the Kelvin of something, which we're not going to get into. No way. Kelvin is much more complicated than Fahrenheit and Celsius. So let's erase that Kelvin. And rewrite our Fahrenheit and Celsius again. Capital F is Fahrenheit. Capital C is Celsius. Capital K is Kelvin, but you don't need to know that for now. Except you already did, because I told it to you. Oopsie. Anyways, these are the two scales we're focusing on right now. Celsius is different from Fahrenheit, because if you look over here, Fahrenheit measures the temperature differently than on Celsius. Fahrenheit and Celsius measure different temperatures. So, for example, if it is 85 degrees Fahrenheit, it will not be 85 degrees Celsius, because Celsius is the different scale. So if it's 85 degrees Fahrenheit, it will not be 85 degrees Celsius. It won't be the same number. All right. So now, we are going to look at all these temps. That's right, temp is short for temperature. And we are going to write them. Let's look at number 4. What do you notice about this one? There's 10 and 20. There's a positive 10 and a positive 20. Remember, it's going above the water, which means that it's positive. It must be a positive value But what is it? How many ticks are there? 1, 2, 3, 4, 5, 6. There are 6 ticks between 10 and 20. And 1, 2, 3, 4 ticks between the 2 large ticks. So, how do we get from 10 to 20 this way? Well, we could do it with 1s, but that would take a really long time. But we could do it with 2s. 12, 14, 16, 18, 20. Yes. So, what is 4? Let's count. 12, 14, 16. Yes. 4 must be 16 degrees Fahrenheit, which means it will not be 16 degrees Celsius. However, there is one exception to this rule. There is a certain negative temperature scale at which both the Fahrenheit and Celsiuses are the same. I just don't know which. But I think it's close to a negative 40 or something. I don't know. Let's just make a prediction over here. Negative 40 degrees Fahrenheit would be negative 40 degrees Celsius. I'm not very smart. Like, as a dog, it's not very smart to tell the difference. But there is one exception where the Fahrenheit and Celsius scales are the same number, which is, I think, close to this. You know what? Let's just continue. Anyway, so that would be 16 degrees Fahrenheit for number 4. Let's look for 5. 5 is over here. There's 10. Oh, but this is 2 less than 10. And what's 2 less than 10? 8, of course. So that's a positive 8. It goes above. So 8 degrees Fahrenheit is for 5. For 6, it would be 2 more than 0, which is 2. 2 degrees Fahrenheit. And then for 7, do you notice how it points straight to the middle of the thermometer? That is the middle of the thermometer. And that is 0. Guys, the middle of any number line is always 0. The exact middle is 0. So, 7 would be 0 degrees Fahrenheit. And for 8, it would be 4 degrees below 0. Remember, below 0, under the water. It's time for some negatives. Negative 2, negative 4. Yes, negative 4 degrees Fahrenheit is for 8, which means number 9 must be negative 12 degrees Fahrenheit.
Yes.
And 10 must be negative 18 degrees Fahrenheit, because it is 2 degrees greater than negative 20. But you might ask yourselves, 18 is less than 20. Why is negative 18 greater than negative 20? Well, guys, let's think of it as an ocean. Let's draw the ocean again. So if you go below the water and the lowest point is negative 20, what do you think negative 18 rests at? Probably a bit higher, right? That's why negative 18 is greater than negative 20. Because it's higher than the negative 20 distance. So, that's why negative numbers with the smaller amount of 10s are actually greater than the negative numbers with the larger amount of 10s. In which case, negative 18 is greater than negative 20. Because remember, it's going slightly above the water more. That's slightly positive. So, negative 18 is greater than negative 20. We're going to talk about that in a second. For right now, let's practice on these. Now, write the opposite temperature. So now we are focusing on writing the opposite temperature, not the temperature itself, the opposite temperature. So 11, we instantly know. Okay, it has to be 2 less than 20. It's 18. But wait, it says write the opposite temperature. Well, what is opposite of 18? Remember, what's the opposite of positive? It's negative, so it's the opposite of positive 18. Negative 18? That's right. The opposite of 18 is negative 18, sorry. So now, this one measures Celsius, so now it will be different. It would be negative 18 degrees Celsius for this one. And for 12, it's the opposite of a positive 10, which is a negative 10. Then for 13, it doesn't rest exactly, but it's roughly negative 6 for the opposite. Because it doesn't land here, but it rests between here. So we'll say -6. For 14, though, you might think, oh, it's below 0, so it's a -2, right? Going below the water. But it tells us to find the opposite of that. The opposite of -2 is a +2. So that'll be 2 degrees Celsius for 14. And for 15, the opposite of -10 is a +10. So 10 degrees Celsius for that one. For 16, that would be 4 degrees less than -10. It's less because it's below the water more. All right. But then the opposite of -14 is a +14. And then for 17, the opposite of -20, a +20. And that's how we find temperatures and opposite temperatures. Well done. All right. Now, here's a super challenge. Write the opposite temperature for exercises 4 and 8 above. Go.
Let's see. Exercise 4 says 16 degrees. The opposite of +16 is -16. So is that the opposite?
That's right. The opposite of +16 is -16. Well done. But now, what about 8? It's a -4, so is it -4? No, Byron, be careful. Look, it says, write the opposite temperature for exercise 8. Not the temperature itself. Oh, right, the opposite of that. What's the opposite of -4? +4, and that's 4, right? It has to be. That's right, Byron! It's a +4. +4 is the opposite of -4, because positive is the opposite of negative. Well done!
Wow, we are so smart!
Yes, now we are going to be learning even more. Usually we finish when the first lesson is finished, but we're not finishing there, because there is more to explore, remember? Vocabulary time is up on the board.
Wow! Let me look at those. Origin, positive numbers, negative numbers, integers. I don't really understand what those words mean.
Don't worry, I'll help you out. The origin of a number line is the point at 0. So, think about the word origin. When you think of the word origin, what comes to mind? Oh, my name except pronounced with a J sound? Origin instead of Oregon? Darn. No, Oregon. We're talking about the origin.
Oh!
Right. Darn. How about the word orange with an N in it? No, it's not orange. Let me show you what origin really looks like. So it's not orange with N in it, and it's not origin with the spelling of your name. No, you're in Oregon, not origin. The origin is the beginning of something too. So let's think of the origin of our world. Now, you may not know the origin of our world because you're only 6th graders, and even the adults watching this will be puzzled. Some adults will understand, though. So, let me explain the origin of the world. Alright, the origin is the beginning of something. And the beginning of the number line is 0. 1 may be a good start, but that's only for the positive numbers. 0 is the actual beginning, because we start with nothing, and then we add 1 more to it. That starts the official beginning. So those bonds are connected together. It's the same thing for how our world came to be. So, the origin of our world is the Big Bang.
Wait!
Isn't that like the Big Bang television series? I loved it. No, it's not the Big Bang TV series. No, it's not with Sheldon Cooper. No. This is the actual Big Bang. What actually happened roughly 14 billion years ago. 14 billion? Is that a positive 14 billion, right? Yes, positive 14 billion. 14 billion years ago, energy just suddenly corrupted and caused all our planets and stars to form. That's the origin of our planet. The origin of numbers is more complex, which I will not explain fully, but I will explain the other part. So, back in prehistoric times, When people had a lot of hair and didn't know anything, they had to invent numbers. So that came to naming numbers different names first before actually naming them with their correct names. So they might have named their numbers Cipher, for instance. Cipher. This is just a hypothesis. It's not actually true, but they may have named numbers completely different names just to understand it. But then, when that name got translated in the official dictionary, which was developed much later, it translated to the number's proper name, which we now know as 0. That's how numbers came to be. And the origin of all of those starts with a little circle. 0. Think of the Big Bang. The Big Bang was probably in the shape of a circle when it exploded, right? All the energy came out. And that large circle was probably the singularity at which it exploded. So, the Big Bang was probably shaped like a circle. So that's the origin of our world. Well, 0 is a circle too. If we look at it, that's a circle. We could draw all the energies again, and it looks like our sun. The sun is not the origin of our world, though. But it is essential for all known forms of life in the world. So, 0 is the origin of the numbers. So we start with nothing, and then we progress from nothing to one thing, and then from one thing to two things. Those things all connect to each other. And if we were to subtract it, we would start with nothing, then with negative 1 of something. Sorry, I'm starting to stutter. Negative 2 of something, negative 3, and so on. So, yeah, it's the same for the Big Bang. The positive thing we would be going for is what goes beyond the Big Bang. Like our planets, stars, and galaxies. If we were to go to the negative value, which is negative 1, negative 2, etc., we would see that there are also black holes there, which is also associated with negative things, because black holes are very dangerous. See, negativity. Sorry, stuttering really affects my mood. So you see, that's how the origin is being described as. Positive numbers are to the right of or above the origin, so it's above 0. So the stars and the galaxies were created after the Big Bang. After might be another word for positive, so it went after this one. Let's draw a line to represent it. B is for before, A is for after, and 0 is when the Big Bang just happened. So after is to the right of the number line. The A is positive because it goes to the right. So that's positive. After means positive 2. However, negative numbers are to the left of or below the origin. Now, we don't know what happened before the Big Bang. Before would be negative, before the Big Bang actually happened and before all of that positivity energy was released. We don't know exactly what happened, but these analogies are great for exploring positive and negative numbers, especially that rough estimate I was trying to draw, negative 40 degrees Fahrenheit and negative 40 degrees Celsius. I don't know if they're exactly the same. I think they are. I think I have to double check. I think they are. So anyway, that's enough for this one. The set of integers includes whole numbers, 0, 1, 2, 3, and so on, and their opposites. Integers represent both distance measured in unit lengths, shown by the numeral, and direction, shown by plus or minus. Now, here is another thing to remember, guys. An integer is always going to be a number, no matter what, because it always represents a value. So, let's draw 0. 0 is a number, right? Yes, we all know 0 is a number. Well, is it an integer, that is? So it sits between the number line, and since it makes up all the other integers, 0 is an integer. So yes, 0 is an integer. And although it's not positive or negative, it is still an integer, because it belongs in the system. It pretty much fits the pattern. Like, you know, cubic numbers, which we talked about previously. 1, 8, 27. 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. But 1 is itself times itself times itself. 1 times 1 times 1. 1 fits that pattern. So it's the start, the origin. So 1 is the smallest cubic number. All right. What do the loops on each number line show? Let's think about this. Oh, wait a minute. That loop is going up from 4 to 5, from a positive 4 to a positive 5. And when you go down it, it goes down from negative 4 to negative 5. I think it represents distance. That's right, Romeo. It represents distance. If you look at a number line and you draw loops, you see how these numbers are progressing no matter which way you go. It always adds or takes away 1, no matter which way you go, up or down. On the horizontal number line, how do the arrows for positive 2 and negative 2 show both direction and distance? Let's look over here. So it's not the positive 2 or negative 2 we're focusing on. It's these that we're focusing on, the arrows. The arrows are another great way to represent distance. 0 minus 2 is negative 2. 0 plus 2 is positive 2. So these arrows also represent distance, and they can also represent direction. To the left is negative numbers. To the right is positive numbers. Both direction and distance. And it's the same thing for positive 5 and negative 5 on the vertical number line. See? It goes up 5 or down negative 5. So, those are both distance and direction. Up and down, positive and negative. We're getting the hang of this. Are 2 and negative 2 and 5 and negative 5 opposite integers? Well, yes. Because if we look here, negative 2 and positive 2, 2 is 2. They're the same number, but look at the plus and minus signs. The only difference is the sign. So, both of these are 2, but the only difference is the sign. So they must be opposites, because the opposite of one line is 2 lines. See, 2 lines makes a plus. 1 line makes a minus. The opposite of 1 is either 2 or 0, but we should represent 2 to represent the plus, because the plus is made out of 2 lines. Negative 2 is the opposite of positive 2, because negative is the opposite of positive. So that's what opposites are. The arrows at the end of each number line mean that it goes on and on forever. Look at that arrow over there, that shaded arrow. Do you notice how it goes down negative 5? Well, we don't have to stop there, because number lines go on forever. Because there are infinitely many numbers. Negative 80, negative 237,572. That's a very, very small number, and a very large number there. So now, that'll be a positive or opposite of those numbers, which makes more numbers. So there are infinitely many numbers, which is why we represent it as a number line instead of a number line segment. In geometry, if you remember, line segments have a certain length, but lines go on forever. A number line goes on forever with numbers labeled to them. So it makes sense to call it a number line instead of a number line segment. All right, here's a challenge. Say a 3-digit number and its opposite.
Well, if I were to say a 3-digit number, it must have 3 digits in it, right? That makes sense.
Yes. And a 3-digit number, let's think of a 3-digit number. 695 is a 3-digit number.
Yes! 6 hundreds, 9 tens, and 5 ones. 695?
But what would be the opposite of 695? It's negative 695, because the opposite of positive is negative.
Oh, yeah!
That's right. The opposite of positive 695 is negative 695, because the opposite of positive is negative. Well done, you two. It's very easy to see that we can just represent any number on a line if we just do these basic steps. Did I do this right? Look, it's Puzzled Penguin. Hi, Puzzled Penguin.
Oh, hi, guys.
I'm struggling here. Can you help? Yes, of course. Happy to help. What's your problem? I made these 2 number lines. Number line A and number line B. But my friend said I was wrong. Can you explain the mistakes I made? Your friend Puzzle Penguin. Let's look at number line A. 0, -1, -2. Wait, just a doggone second. What is a -1 and a -2 doing at the right of a number line? That is not right. A +1 and a +2 at the left? No, that's not how it works. That's the error you made, Puzzle Penguin. On number line A, negative numbers should not go to the right. Positive numbers should not go to the left. No, negative numbers should go to the left, and positive numbers should go to the right. So you see, think of it as correct and incorrect. When you get something incorrect, you might feel negative or disappointed that it was the wrong answer. That's negative. But when you get it correct, that feels right. Right is a direction, and right also means correct. Right means two different meanings, correct and the direction right. So that's how you can know positive and negative. Negative is wrong, like incorrect, and positive represents correct or right. See, right, right, and right. Those are the same words. So sorry, Puzzle Penguin, you have to swap those numbers around.
That's okay. Number line B. I think I swapped
Them now. I hope I did well. Let's see. +1, +2, above the water. Yes, you did vote. You did those right. -1, -2. Wait just a doggone minute. What's this gap? Have I not noticed this gap before? What is a gap doing here on the number line? You know there shouldn't be large gaps on the number line. You should make equally sized gaps for every number.
Oh, sorry.
It's okay. -2 is only 1 less than -1. Not 2 times less. That's way too less. So you need to scooch it here instead of all the way here.
Oh, okay. Thank you for fixing my mistakes.
No problem, Puzzle Penguin. No problem at all.
See you later.
Bye. All right. Number lines can go on forever and ever, and they can have multiple numbers at once. You might just never know what numbers might pop up. But now it's time for an increasing difficulty level. Unit 9, Lesson 3. Compare and order integers. This number line is unique. Look at it. It has -10 and a +10. +10 is the greatest value. -10 is the least value. As you move to the right on the number line, do the numbers increase or decrease? Well, if we move right, then it would be positive numbers, which with each number being one more than the one before it. So that would be increasing. Increase. As you move to the left on the number line, the numbers decrease because we're going negative. Decrease. If two numbers are placed on a number line, is the number farther to the right the greater number or the lesser number? Well, if it's farther to the right, we're going positive. So that would be greater. And if two numbers are placed, is the number farther to the left greater? No, because the number to the left is negative, or at least less than the positive number before it. After it. So, that'll be the lesser number, because we're going lesser. Negative. Yes, so to the left are the lesser numbers, and to the right are the greater numbers. In the middle, there's 0. Right, less than, greater than, or equal to. Thanks to our strategy, we can easily compare these numbers without much help. -1 is greater than -4. And how do we know that? Let's look at it. -4 is to the left of the number line. -1 is also to the left of the number line. But if you fill in the gaps, -1 tends to be closer to the right than -4 is. So -1 is greater than -4 because -1 is closer to 0 than -4 is. So you see, that's why -1 is greater than -4, although a +1 is less than a +4 because that +1 is greater to 0 than +4 is. So if a +1 is closer to 0 and a positive 4 is farther away, then that means 4 is greater than 1. But negative 4 is less than negative 1 because it's farther away. So, those are the complications of trying to compare to such numbers. Negative 1 is greater than negative 4. And 2 is greater than negative 2. What do you notice about these numbers? That's right, they're the opposites, which means 2 is greater than its opposite, negative 2. So look at these two numbers. 2 is to the right. Negative 2 is to the left. Remember, numbers to the left are less. Numbers to the right are greater. So that's why 2 is greater than negative 2. 2 is greater than its opposite. And then we can compare the rest of these numbers without any problems at all. And if we look here, negative 8 is equal to negative 8. That's obvious. The same number. No change in size and no change in number. And 0 is greater than negative 7 because 0 is closer to the right than negative 7 is. That's how we can compare positive and negative numbers. So if we are asked to order them from least to greatest, that wouldn't be any trouble at all either. Because we can look at the negative and positive numbers, or in this case, 0 if it is not positive or negative, and see if it's closer to the left or right. So negative 2 is on the left side. Negative 1 is a little bit further, and 0 is the furthest. So negative 2 is the least. Negative 1 is in between, and 0 is the greatest. Because they are moving right, which is greater. Least to greatest. So, but if it asks us for greatest to least, then we move the other way. Right to left would be greatest to least. So that would be 5, 0, negative 1, negative 3. Right to the left. See? That's how it works. Right to left is greatest to least. Left to right is least to greatest. Think of it. Least starts with L and left starts with L, right? So that is another great way to remember it. And greatest has an R in its name, and right has an R in its name. That's how you can also remember. And thanks to this method, we can compare any positive or negative number. And now, here's something I think will make you totally excited. This is another fairly easy topic. In fact, it's one of the easiest of all. There is a symbol with 2 vertical bars in it. It's used to indicate absolute value.
Cuckoo? Absolute value? What's absolute value?
Absolute value is a measure of the distance a number is from 0 on a number line. This number line shows that 4 is a distance of 4 unit lengths from 0. So let's look at 0. There is a blue tick here above the black tick. That means the blue tick is the arrow. If we move right 4 times, that would be a positive 4. So that's 1, 2, 3, 4 distances away from 0. Because 4 is 4 unit lengths from 0, the absolute value of 4 is 4. And we recorded that fact by writing 4 between the 2 vertical bars equals 4 without the 2 vertical bars. Since absolute value is a measure of distance, and the distance between 2 points can never be a negative number, absolute value is never a negative number. Look at this. The absolute value of negative 4 is still 4, because it is 4 distances left of 0. And 4 distances left from 0, in that sentence, 4 is a positive number we're saying. Negative 4 is 4, positive 4, distances away from 0. So see, the absolute value of negative 4 is positive 4. However, if we were to find out the opposite of the absolute value of positive 4, that would be negative 4. You want to know why? Because the absolute value of 4 is 4, but the opposite of the absolute value of 4, which is 4, is negative 4. I taught very fast, so let's try this again. The absolute value of 4 is a positive 4, and the opposite of a positive 4 is a negative 4. So the opposite of the absolute value of a positive 4 is the opposite of a positive 4, which is a negative 4. That still might be complicated. I talk much slower, but That's a tongue twister to really understand. But if we are not finding the opposite of absolute values, then absolute values can never be negative numbers, and they never will. Because the distance, we are saying, is a positive statement. 4 distances away from 0. Not negative 4 distances away from 0. That doesn't make sense. This number line shows that negative 3 is 3 unit lengths from 0. Look at that. Positive 3. So the absolute value of negative 3 is a positive 3, thanks to this statement. Because negative 3 is 3 unit lengths from 0, the absolute value of negative 3 is 3. And we record that fact again by this. Absolute value is a measure of the distance a number is from 0 on a number line. So the absolute value of 0 is 0. Guys, we just mentioned this earlier with the Big Bang. The origin, remember? Not orange in or Oregon. That's silly. Now, 0 is not a positive or negative number at all. So the absolute value of 0 is itself. It's not positive or negative at all. Oh, good morning, Woofer! Ruff, ruff, ruff. Ruff, ruff, ruff. Ruff, ruff, ruff. Wow, you heard everything I just said? Wow, you have super hearing, even when you're sleeping. Ruff, ruff. Yeah. Wow, that is right. The absolute value of 5 is 5. How did Woofer figure that out so quickly? Because Woofer knew that if we turn right on the number line and we stop at 5, that's 5 distances away from 0. So the absolute value of that number is 5, because the absolute value of 5 is 5. It's 5 distances away from 0. So the absolute value of negative 1 is not negative 1, you guys. It's a positive 1, because it's 1 distance away from 0. And that 1 distance, 1, that positive word, the absolute value of 2 is 2. The absolute value of negative 4 is positive 4. The absolute value of negative 2 is positive 2 also. The absolute value of 3 is 3. The absolute value of 0 is 0. And the absolute value of negative 5 is a positive 5. So you see, an absolute value is always going to be positive, never negative. If we write a negative sign in front of it, then it would be negative. But it's not negative by this rating. Not including this. It's not negative for this. That is read. The opposite of the absolute value of a positive 4. The absolute value of a positive 4 is a positive 4. But the opposite of that would be a negative 4. So that's negative 4. But the absolute value in those bars is not negative. Only the opposite makes it negative, not the absolute value. The absolute value doesn't make the number negative. Only the opposite negative sign does. Only this does. Not the bars. Not the absolute value bars. So that's why absolute value is never negative. It's always going to be positive. Okay, seems like we are having trouble with our whiteboard today. Don't worry, it kind of always acts up sometimes. Alright, sure. Oh, wait a minute. I drew it with this, my pen. I'm supposed to draw it here. Silly me. Alright, I'll erase this later. Anyways, the absolute value of any positive or negative number is always positive, never negative. So that means the absolute value of positive 10, 10. Negative 18, the absolute value of negative 18, positive 18. The absolute value of positive 25, positive 25. The absolute value of negative 30, positive 30. So that's how we could represent absolute value.
I'm having trouble again.
Oh. We know. Tell us your problem. Well, I decided that the greater absolute value is the greater number. So I wrote 10 is greater than 5 and negative 10 is greater than negative 5. Can you explain to me what I did wrong? Your friend Puzzled Penguin. Well, 10 is greater than 5. Well done. Wait just a second. Negative 10 is less than negative 5.
Why?
Because negative 10 is to the left. negative 5 is to the right of negative 10. The right is greater. So, you're wrong on that one. Negative 10 is less than negative 5. And negative 5 is greater than negative 10 because it is closer to 0 than negative 10 is. So that's why negative 10 is less than negative 5, because it is closer to negative 10 than to 0. It is negative 10 in itself. So negative 10 is less than negative 5.
Oh, I'm sorry.
That's okay. We all make mistakes all the time. Now, anyways, you know what's also amazing about absolute value? We could also represent it with numerical expressions. We learned what numerical expressions were in algebra last time, remember? Numerical expressions are expressions that involve numbers. Order of operations again. We learned about the order of operations. PEMDAS, please excuse my dear Aunt Sally, or parentheses, exponents, multiplication, division, addition, subtraction. So we follow parentheses first. But for absolute value, we do something different. Step 1, perform all operations inside parentheses and within the absolute value symbols. So, for example, here, there are no parentheses, which means the first step is the absolute value symbols. So, the absolute value of negative 5 is a positive 5, and 5 plus 7 is 12. Because 1, 2, 3, 4, 5, 6, 7. Yes, that's 12. So, the absolute value of negative 5 plus 7 equals 12. Because the absolute value of negative 5 is a positive 5, and 5 plus 7 is 12. That's a positive 12. So, that's how we can figure it out. Now let's go over here. This is a parentheses-like situation. 6 minus 4 is 2. That's the parentheses completed. But the absolute value symbols is not. The absolute value of 2 is 2. So step 1 is completed now. So now it's 2 times 5 plus 3. Multiply is first, and add comes last. So 2 times 5 is 10, and 10 plus 3 is 13. So you see, by doing this, we could easily figure this out. 7 minus the absolute value of negative 3. The absolute value of negative 3 is positive 3, meaning that 7 minus a positive 3 would be taking away 3. 7 minus 3 is 4, a positive 4. For this one, there's exponents. Look at it. There's an exponent here. 2 to the power 3. But we have to do the absolute value first. The absolute value of negative 15 is a positive 15. So now it's 15 minus 2 to the power 3 plus 1. 2 to the power 3 is 2 times 2 times 2, which is equal to 4 times 2, which is equal to 8. So now it is 15 minus 8 plus 1. So addition comes first. Subtraction comes last. So that would be 8 plus 1, 9. And 15 minus 9, that would be 6. So, yes, that's how we do it. This is how we do it. Woo! And, this is only one way to do it. There is also another way to do it, which is much, much harder. For the more proper answer, you could also add negative 8 and a positive 1 together to make negative 7. Then 15 minus 7 would give you 1, 2, 3, 4, 5, 6, 7, a positive 8 as well. So it would be 6 or 8. Both of those answers are acceptable. But I think it's 8. So I think I did that one wrong. But don't worry, we all make mistakes. This one, alright. 11 minus 5, buckle your seatbelts, is 6. Absolute value of 6 is a positive 6. And 4 times 4 is 16. So now it's 3 times 6 minus 16. Multiplication is first. 3 times 6 is 18. And 18 minus 16 is 2. Wow, 2. All that work just for 2. And then for this complicated one, there are 2 of these. 2 absolute values we have to solve this time. 10 minus 3 is 7. Absolute value of that is still 7. Absolute value of negative 8 is positive 8. 4 times 7 plus 8. Multiply first. 4 times 7 is 28. 28 plus 8 is 36. So that is 36. So yeah, you'll be able to learn all of this extremely quickly. We can also do it for algebraic expressions if we evaluate a, b, and c for specific values. Evaluate each expression for a equals 6, b equals 10, and c equals 5. So if we look at this, this is the absolute value of b minus a. Well, what's b? B equals 10, right? So 10 is substituted for there. And then a equals 6. So 6 is substituted for there. So that would be the absolute value of 10 minus 6, which is the absolute value of 4, which is 4. That's it. And then for this one, it's very tricky. A equals 6. Now, you may think a equals negative 6 because there's a negative. But wait just a minute. This is not a negative 6. This is a positive 6. So, a for 6, that'll be negative 6. The absolute value of negative 6 is positive 6. C is 5, so the absolute value of negative 5 is 5. The absolute value of negative 10 is 10. So that would be 6 minus 5 plus 10. So addition comes first. We could do this two ways. 5 plus 10, 15, minus 6 is 9. Or for a more professional answer, negative 5 plus 10, because there's a minus sign, would be 5. I believe so. And then 6 plus 5 is 11. So it could be 9 or 11. I think it's 11, though. Again, made that mistake. Don't worry. We are just learning here. So, 9 or 11 are good choices for this one. And now for this one, this is very complicated now, but we know the absolute value of negative a must be 6, because the absolute value of negative 6 is a positive 6. And now, c squared. C is 5, and 5 squared is 25. And the absolute value of b is 10, because b is 10. 6 times 25 minus 10. 6 times 25. Multiplication is first. So 6 times 25 is 25, 50, 75, 100, 125, 150. So it's 150. Minus 10 is 140. So it's 140 for this one. How did we get 6 times 25? Well, we skip counted by 25s 6 times. 25, 50, 75, that's 3 times. 100, 125, 150, that's 3 more times. 3 plus 3 is 6. So 150 is 6 times 25. Minus 10 is 140. And now for this one, wow. 3 at once. B minus A plus C. That would be 10 minus 6 plus 5. 10 minus 6 plus 5. Alright, 10 minus 6 plus 5. We could do this two ways. 10 minus 6 plus 5 would either be 9, because 10 minus 6 is 4, and 4 plus 5 is 9. Or, negative 6 plus 5 is negative 1, and 10 minus 1 is 9. Oh, wait a minute. Those are the same. So it's the absolute value of 9, which is 9. 9 plus 6 squared. 9 plus 6 squared is 36. 36 plus 9. 36 plus 9 is 1, 2, 3, 4, 5, 6, 7, 8, 9. 45. I think I answered this one wrong. Sorry, I wrote 37 for this one. It's really 45. How did we get that? 6 squared, 36. 10 minus 6 plus 5. Oh, 10 minus 6 is 4 plus 5 is 9. 9 plus 6 squared, 9 plus 36. Add 10, take 1 away. That's one way to add 9, because 9 is 10 minus 1. So if you don't know the 9 times table, you can just add 10 and take 1 away to figure out the next number. So 36 is a multiple of 9. 9 more would be adding 10 and taking 1 away, which is 46 minus 1, which is 45. 45 is the answer for this one. And then for this one, wow, it's the last one. 2 times the absolute value of negative 10. 2 times 10, because the absolute value of negative 10 is a positive 10. 2 times 10, 20. Minus the absolute value of A plus C. 6 plus 5, 11. Absolute value of 11, still 11. So 20 minus 11 is 9. So see? Look, 20 minus 10 is 10. But 10 minus 1 is 9. So 20 minus 11 must be 9. Plus, we can check with addition. 11. Add 10, that's 21. And take 1 away, that's 20. That's right. So 20 minus 11 is 9. Phew! We got there in the end. Phew. That is a lot of hard work. Usually, you will have to do all those steps just to get those correctly. But I don't think it's too hard. Alright, that is it from us today for now. Come back for another math lesson. I hope you enjoyed this video about positive and negative numbers. And we'll see you all again real soon.
Bye! Bye!
Can someone help me erase this? Sure.